Ladies and gentlemen, what's up with all these numbers? Well, remember, in class, we talked about all of these numbers creating these things right here when we all situated them, the Pythagorean triples. Remember, they were shortcuts to be able to find different side lengths of triangles. So if you knew one side of a triangle was 5 and the hypotenuse was 13, you right away then knew that 12 was the other side. And all the other ones, 8, 15, 17, 7, 24, 25, 9, 40, 41, and the one that's not on here is 3, 4, 5. So those are the 5 Pythagorean triple families that we discussed about in class. And remember, there's a bunch of siblings that come from them. However, here's why I'm showing you this, because what this video is going to be about is actually section 7, and I'm going to do 2-part videos. Part video 1 is going to be on one theorem. Video part number 2 is going to be on a second theorem. And this first one you're going to see, here's the essential question. How do you find the side lengths of a 30, 60, 90 triangle? Now wait a minute. If I go back to those Pythagorean triples, remember 3, 4, 5, 9, 40, 41, they all had 3 different numbers. Well, listen, 30, 60, 90, you might be thinking, ooh, is that another Pythagorean triple? And my friends, you could check it, but it's not. 30 squared plus 60 squared is not equal to 90 squared. Doesn't work. So then what in the world am I talking about? Well, you're going to find out in this particular video. So what I do into your notes, draw a simple little triangle, A, B, and C. It's a right triangle. You got the old right angle right there, so you know it's a right triangle. And let's kind of set the stage for you. Let's say that one side is 10 root 3. So I'm going to say CB is 10 root 3. And I'm also going to say 20 is the hypotenuse. So what I'm giving you here, technically, guys, is 3 things that you know. One thing you know is it's a right triangle. Second thing you know is one side length. Happens to be the hypotenuse. Doesn't matter. And a third thing that you know is another side length. So 2 side lengths and a right angle. That's 3 pieces of information you know. Just from that information, if I ask you to find AC, X right there, that guy right there, you could easily do it, and you would always say, wait a minute, this isn't a triple. I agree with you. 10 root 3, 20 is no triple family whatsoever. But you can use a Pythagorean theorem, and you can take the 20 and put it up in here for the C squared. You can put the 10 root 3 in there for another leg, and X is the other leg. So by solving this goofy thing, let me get a, okay. So by solving this thing, as you see, 10 root 3 squared over here, I did that for you. It's the same as 10 root 3 times 10 root 3, and that means you take 10 times 10, the thing's out of jail, and you get 100. Root 3 times root 3 is the same thing as the square root of 9, which is just 3, which means this whole thing right here is 300. So this guy goes to 300. 20 squared is just 400. When you subtract away the 300 right here over to this side over there to the right, that gives you 100. Just simple Pythagorean theorem. Square root both sides, you get a nice answer of 10. Piece of cake. Nothing to it whatsoever. Now, what happens, ladies and gentlemen, if I take away the Pythagorean theorem and I actually take away the 10 root 3 and the x? And now I tell you, wait a minute, I only have 20, that's right, and I only have the right angle, that's right. I'm going to teach you a nice little shortcut. Actually, I already did teach you. I'm just going to show you what it is. You don't know it. I'm going to show you a shortcut with this next theorem that's going to allow you to do it just as fast as the Pythagorean triples. However, very important, you need one more piece of information to make this work. 20 is great. The right angle is great. You need one more piece. Just like when we went back to this, when I said, hey, look, we got one side, a second side, and right angle. We had 3 pieces. That's the only way that we know that it could work with the Pythagorean theorem, by finding x right here. I got you. But when we do this, and we take away the x and the 10 root 3, we need one more thing. And let's say, here's the scoop. That little 30 that threw in there. Oh, buddy. If we know that that angle is 30, and we know that this side is 20, and we know that that angle is 90 degrees, well, there's your 3 pieces, and that is enough. 3 pieces of information, that's enough for you to find this side over here, AC, and this side right there, CB. I know, you're thinking, no way. Oh, yeah. And I'm going to tell you very quickly in this next theorem. And here's what it is. Oh, I should have told you this. Sorry, it just flew in there. I'm glad I did. That little 60, remember, you should know that pretty quickly, because if this is 30 and that's 90, simple math would allow that to be 60. So, oh, wait. There's your 30, 60, 90 triangle. Oh, that's what the theorem talks about. Exactly. So when you have a triangle where there are angles that are 30, 60, 90, it actually always breaks down into a particular ratio. And here's the wording that needs to go into your notes. So in a 30, 60, 90 triangle, this is the theorem, theorem 72. So in a triangle whose angles have the measure of 30, 60, 90, the lengths of the sides opposite these angles can be represented by x, x root 3, and 2x respectively. What in the world does that mean? That means this. Across my 30-degree angle is what x is. So in your notes, you need to make sure you write this down and burn it to memory, just like the Pythagorean triples. Across my 30-degree angle, that's what x is. Across my 60-degree angle, that is always what x root 3 is. And across my 90-degree angle, the hypotenuse is always 2x. Always. So if you go back to the example that I had before, I'll just write it down here. We had this side, remember, was 20. This side over here, remember, was 10 root 3. And remember, we actually found this side right over here to be 10. Check that. Whoa, that was weird. Found that to be 10. So check this out. As soon as I know that x is equal to 10, all I really do is just take this 10, which is x, and plug it in here, and I get 10 root 3. And I plug it in here, and I get 2 times whatever 10 is, which is 20. That's all you have to do. This is really cool. So then the goal becomes finding x. As soon as you find x, as you see it popping up here on the screen, the goal is as soon as you find x, then plug it into all the other 3 sides. Well, actually the other 2 sides, because as soon as you find x, this piece right here, then the x goes here and here. What do you mean, Mr. Motter? Quit confusing me. Well, if I knew that this side happened to turn out to be, I don't know, 5. I'll just make it up. As soon as I know that this side is 5, the side across my 30-degree angle, that means this side has to be 5 root 3, because I can just plug in the 5 for x. And I know this side over here has to be 10. It is that simple. What if I know that this is, I don't know, 11? Great, then I know this is 11 root 3, and that's 22. What if I know that this is 9? Great, as soon as I know that that's 9, then I know that this is 9 root 3, and that's 18. That's exactly how it works every single time. So let's do a couple of examples so you see how this thing really does work. Okay. How do I get rid of this thing? There we go. There we go. Okay, so the example is this. Put 30, 60, 90 triangle in your notes, and let's put this side over here to be 6. Well, the question is to find the other 2 remaining side lengths. Well, how am I going to do that? What I'm going to do is this. According to the 30, 60, 90 triangle, across my 30-degree angle, that's what x is. Across my 60-degree angle, that's what x root 3 is. And across my 90-degree angle, that's what 2x is. So my goal, as this little guy over here reminds us, the goal is to find x. Hey, check baby, 1, 2. We already got it. So therefore, since x is equal to 6, as you see, it's a simple little equation. That means this piece right here has to be 6 root 3. So that side's done. There you go. And this side, if I put the 6 in here, gives me 12. So there are your other 2 side lengths. One is 6, one is 6 root 3, and one is 12. Now that's very simple, but that is the goal. Find whatever x is and then plug it in. That'll help you with the remaining proportional sides of a 30, 60, 90. Let's keep going. Let me give you another one. So let's move this 6. Can I do it? Yeah. Let's move the 6 over here. So now, same question. Let's find the other 2 legs, the other 2 side lengths. How do I do it? Well, here's what I know. Across my 30-degree angle, that's what x is. Across my 60, that's x root 3. Across from my 90, that's what 2x is. And bada bing, bada boom, there is your equation. So at some point, when you just plug in the Pythagorean theorem, when you just plug in the 30, 60, 90 triangle ratios of x, x root 3, and 2x, you're going to come up with an equation somewhere. And here's my equation. What do you mean? There's my equation. This side's supposed to be 2x, and it actually is equal to 6. So if I solve this by dividing each side by 2, oh, look. There is x value. So as soon as I find the x value, I'm done. I just got to plug in the 3 right there. So this side length is 3, and this side length is 3 root 3. And, ladies and gentlemen, I am done. There you go. Let's do one more example, see if it works. Here we go. Let's move the 6 now down to the bottom. This one's a little tougher, but it's going to be fun. So according to my 30, 60, 90 triangle theorem, across my 30, that's x. Across my 90, that's 2x. across my 60, oh, there's your equation. I'm going to get x root 3. Now, there's a little more work involved with this one. I have to solve this equation right here for x, because as soon as I get it, then I can plug it in here, and plug it in here, and I'm done. Well, change color. Okay, here we go. So I have to solve this for x. Well, how do I get rid of x multiplied by root 3? I have to divide. To undo multiplication, I have to divide. And to get x by itself, I must divide by root 3. So what does that leave me with? Well, that leaves me with a weird answer. I'll have to clean up. So I get these guys cancel out. I'm left with x equals 6 over the square root of 3. Okay. Time to rationalize the denominator like we talked about in the first part of this chapter. How do I do that? Well, I have to multiply. Let me change color. I have to multiply the top and the bottom by the same thing, but it's got to be a funky looking 1 because I don't want to change the value. Why does it do that? That's weird. That's a 3. Weird 3. So I don't want to change the value of 6 over root 3, so I'm multiplying by a funky looking 1. But when I do this in the denominator, that gives me the square root of 9. Oh yeah. And that equals in the top 6 square root of 3. Well, let's keep going, because the square root of 9, last I checked, is just 3. So what I have in the numerator is still 6 root 3. And then I have square root of 9, which is 3. Okay, let's keep going. So now I can reduce the thing out of jail and the thing out of jail. I can reduce that. This reduces, that crosses off. That's an ugly green, whatever. And that crosses to a 2. So what happens then? This whole thing is 2 root 3. Why did I do all this work, Mr. Motter? This is crazy. Because what I just found, x is equal to 2 root 3. Ba-bam! That was the goal, to find what x is. So what does that mean? I take the x, or 2 root 3, and I plug it in here. And there's my answer for that side. That side length is 2 root 3. That's this one, because that's what x is. This side length is already 6. We were given that right there. Sorry, it's ugly, but that's what it was. And then I have to take 2 times whatever x is. So that's the same thing as 2 times whatever x is, which is 2 square root of 3, which happens to be 4 root 3. So there, ladies and gentlemen, weird question, but it's going to happen. There are your 3 side lengths. 2 root 3, 6, and 4 root 3. So the goal, as you've seen so far, the goal with all these questions, bam, is to make sure that you find whatever x is, whatever the equation is going to be. You're going to have to set up an equation somehow. And then when you find x, plug them in, and you got it. So x root 3, and 2x is your 30, 60, 90 triangle theorem. I see you in class. It's going to be fun practicing these later.